Okay. Good morning, everyone, and we're very pleased to welcome you at the third FOSS day of this year, in which we are going to present a demo event about the FOSSR Virtual Research Environment, a very important platform for enhancing the collaboration among researchers and for easing and facilitating a research and the development of collaborations and the development of the ability to do research in a more deep way and more quality level and more effective way. So I'd like to leave the floor to Mario Ciampi, who is going to introduce this event, and then I want to thank Massimiliano and Alfredo for providing this demonstration. Thank you very much, and we're going to catch up at the end. Okay, bye.
Good morning everybody. Thank you, Giovanni, and thank everyone for being here, connected online, for this interesting presentation about virtual research environment. Virtual research environment is an important environment provided by the plethora of services that the FOSSR infrastructures offers. As this service, this environment offers numerous research features for data analysis, as well as social functions through virtual labs that are able to foster collaboration among all the researchers that intend to cooperate in research each other. So this way, virtual research environment services provide key tools to advance open science practices in the users that can access FOSSR services. It exploits also state-of-the-art infrastructures. So this environment also offers social features, social functions in an infrastructure for social science based on cloud. So I thank the CNR IST colleagues that now will present in detail this environment, and I let them the floor. Thank you again.
Thank you, Mario. Now I'm going to share the screen for starting the presentation. Do you see the presentation in full screen mode?
Yes.
Yeah.
Okay. So let's start. So please let me start this presentation by defining what is open science, and to do so, I will let's say use and the Commission recommendation of 2018. So what is open science? It is an approach to the scientific process based on cooperative work and ways of disseminating knowledge, improving accessibility and usability of research outputs. This is very important, no? The reusability and reproducibility aspect. By using digital technologies and collaborative tools. I always use also, I always like to use this taxonomy that you can see in the slide here. This is let's say a result of a European project that now is handed this named FOSSR. And if you see in the taxonomy, open science encompasses diverse terms. So it's not all open science, not only open access, but also open data and all that comes through it. But when we talk about open science, we also talk about open reproducible research, evaluation, policies, and tools. Now, with respect to open science, what are open science infrastructures? What is an open science infrastructure? It is a shared research infrastructure supporting open science and serving the needs of different communities. So the open science infrastructure can be physical, digital, or hybrid. It can include publication and data repositories, equipment, and other infrastructures for open sharing, evaluation, and reproducibility. An open science infrastructure does not only offer open access repository, because this is one of the, say, features that an open science infrastructure should offer, but not only open access repositories, because repositories typically address only a specific part of the research workflow, while infrastructures are relevant across the entire research lifecycle. So what happens now today? What are the open science practices today? Typically, most of the time, the researcher deposit his paper and the data software in an open access repository. And if the researcher does so, we're happy. However, there is a problem in this, let's say, in this practice, because the open access repository is external to the research place, and this makes it somehow slow and complex to collaborate, and more importantly, to reuse and evaluate the results. So if we work in a data-driven science scenario with a digital infrastructure and in infrastructures research context, maybe then we can propose, we can use a different approach for doing scientific communication. How? Providing the user, the researchers, with direct access to the place where the research activity is performed. What do I mean by so? So the VRE and what we try to do here in ISTE is we propose a sort of paradigm shift. We by using the e-infrastructure service, we are able to couple the place where the research is performed, is conducted, with the place where this research is communicated. And the VRE makes it possible to do so, and to do also more by supporting the entire data-driven research lifecycle. So we have published some work on this that you can find in this slide, but what the VRE offers are mainly, besides, of course, a platform for carrying out your research in an open way, but VRE offers also a number of services that follow and supports the researcher across all all the research life cycle. So the VRE offers a communication platform service. It offers a shared cloud storage service, a data analytics engine to process the methods, the models, and also a publishing platform for sharing, let's say, the research result. Let me try to explain this by using this slide, where you can see a prototypical, let's say, research life cycle. So typically, you start from you can start basically from anywhere, but you start from, let's say, when you have a research challenge, you start by collecting the research data that will be useful for your research. And then maybe you need to use and to import your software or your models into the VRE, and then execute the software over the cloud computing platform of the VRE, which will give you back some research data as result that will go and compose your scientific result. So the FOSS-VRE allows to say cover all these let's say steps that you can see in this slide, and it enables to reproduce, reuse, and evaluate the result, active collaboration, effective sharing, while maintaining provenance and attribution. This is important because in a even if the environment is open, provenance and attribution for researcher is important. And the VRE does so by adopting an as a service approach, a number of standards, and economy of scale to reduce operational results and cost. So let me try to explain these services that I just introduced with this simplified scientific workflow that could be enacted by this component. So let's start by the research challenge, right? So Dr. Ping arrives and he has a research challenge. He communicates that he wants to, or she wants to perform, he has this research challenge and he wants to work on this. Then Dr. Brown and Dr. Blue, they find this research challenge relevant and start importing the datasets that would help Dr. Ping and also themselves in the platform by using the shared cloud storage service. So now Dr. Ping and Dr. Blue, they can work together by importing the models that will analyze those datasets in the platform. In this case, they will use the analytics part of the VRE. Meanwhile, maybe Dr. Orange see this activity in the VRE, and maybe he can start another kind of research. Now, when Dr. Pink and Dr. Blue are, let's say, satisfied by their results, they can publish. So they can, let's say, publish the results of the publication by using this publishing service platform that will basically publish the result in a catalog that is available to all the users. Now, if you see, in doing this, there could be another user, we call it Mr. White, that can assess already and can start the assessment of the research that was carried out by Dr. Pink, Dr. Blue, and Dr. Brown. And you can see here, Mr. White can do the assessment while they are doing the research work and by using the same environment that was used by them for performing this kind of research. Now, if you see this, all of this happens well before the paper about this research activity is published. Now, we did not start by scratch in FOSS with this. Actually, this work is the FOSS-VRE platform is based on D4Science. D4Science is a federated digital infrastructure promoting open science practices, and it is owned and managed by CNR. D4Science is not new. It started with 2 successive European projects in 2008 until 2012 in the 7th Framework European program. And then it was, let's say, recognized and actually formalized in 2014 at the Istituto di Scienze e Tecnologie dell'Informazione, ISTI, here in Pisa. The way that D4Science, let's say, is capable of supporting the research, D4Science serves as a platform for different, let's say, and have served as a platform for different research projects, mostly European Commission-funded projects. So you can see here until 2020, D4Science was involved in different and several Horizon 2020 funded projects, and now it is still, D4Science is still present in Horizon Europe, so the new European framework, but also for the Piano Nazionale di Ripresa e Resilienza. In fact, D4Science supports FOSS for the VRE service. It is also the enabling platform for SuBigData.it, which is another PNR infrastructure, research infrastructure project, as well as the VRE part, most of the VRE of the itineraries project. So D4Science support S3RIs, national and European project, and national and international initiatives. So, and how can D4Science do this? I will try to explain this with this slide here. So you see, D4Science leverage external systems in terms of data storage service and computational resources, cloud computing infrastructures, and expose them in a common unified space of resources. So we have built a software framework that is capable of exposing these data storage services and computational resources in a common unified space of resource. And in doing so, we are able to serve diverse community of researchers with the provision of tailored service and sharing tools. And the way that D4Science makes accessible all these, let's say, resources are through, in fact, these web-based on-demand environments called virtual research environments and virtual labs. So here you see in the slide here, this middle layer is where the software framework of D4Science and also the hardware intervenes. And in FOSS, so let's go back to FOSS. So the VRE of FOSS is, let's say, relying on D4Science for the services of D4Science, and of course for the hardware that FOSS makes available for its operation and its functioning. So this is a very, very simplified, let's say, architecture, but just to give you an overall look of the FOSS-VRE open science services for virtual labs. On the right, you can see the FOSS cloud infrastructure providing cloud, let's say, in cloud infrastructure in terms also of hardware and capabilities, right? And then what D4Science does, it does, let's say, deploy the service that we have been talking, that I was talking about. So it does, it has its own cloud storage service. It has a communication framework, a publishing framework, and an analytics processing service. Now, on your left, I think, you can see that the way that the user can access the FOSS-VRE are basically two. So there is a web front end that we're going to show very soon now, and that is subject of the demo, but everything is also accessible via web API. So the FOSS-VRE, you see, their users can access what we call virtual laboratories, and the virtual laboratories makes available a number of services that are needed for carrying out a kind of research. So the subject of this this presentation today and the demo that we are going to do is the analytics and processing part. Maybe later on during the project we will touch also the other services, but because we did for it is it may be very long, maybe a lot of things. So what we decide to do is to focus and show a demo of the analytics processes part of the FOSS-VRE. Now, from theory to practice. So you may be curious, so where is the FOSS-VRE? So the FOSS-VRE is accessible via a web portal that we call VRE Gateway, so FOSS-VRE Gateway. And it is accessible at the URL foss.d4science.org. Now, when the user wants to use the VRE, the user needs to have, let's say, an identity, right? He needs to be registered. He or she needs to be registered. You can create an account on our, let's say, identity and access management service, but we encourage you to use the academic, let's say, or other login, which exploits the Edge check-in as part of the European Open Science Cloud framework, where you can find not only on the National Research Council identity provider, if you are from CNR, but also your university. It uses EduGain, so it's you can. I'm sure you will find your identity provider of your institution here. This is instead, so we will also see this live, Alfredo is going to show you, but just to giving a sort of preview of what you're going to see in the demo. So this is we call the dashboard page of the FOSS-VRE Gateway. So the page where you land, the first page where you land after the login. So we have made this very easy. So assuming that the VRE can support many virtual laboratories, we have created one virtual lab. We have called FOSS Virtual Lab, this virtual lab, with basically a number of services that you can use by yourself. So when you register, so you arrive in this page, you can click FOSS Virtual Lab, and you will enter the virtual lab. What do you find in the virtual lab? This is the VLab home. So there is here an about, there is, you can see here in the middle, a facility to interact with the other users of the virtual lab by, say, doing a post that can be liked, can be replied, just like any, say, social media we are all used to use. There is on the right a shared cloud storage folder that is accessible to all the members of the virtual lab. And then there are the tools that the virtual lab offers to the users. In this case, we have a Jupyter lab. I will touch them. RStudio, analytics engine, and a catalog, as well as an how-to that explain how to use these services. As I said, the shared folder and the posts. Now, what is, for those who are not familiar with Jupyter Lab, Jupyter Lab offers Jupyter notebooks that are web-based tools that lets you write and run code, display data, and add documentation in an integrated format. When you click Jupyter Lab, you are offered a number of server options. So these are actual servers that you can use to do your research. We have now, for this virtual lab, made available 3 kind of server options. One what you call large with 4 cores and 8 gigas of RAM, a medium with less resources. And then we have one, say, instance called VRE training server with much more resources, 8 core and 64 gigas of RAM that is already being used in, let's say, by some of our users, FOSSR users, let's say, in a preview mode. Now, the added value of this, say, this Jupyter Lab environment is that we can customize these server options with, let's say, predefined libraries that you would need to use when, let's say, carrying out your research. There are a number of programming languages that can be used: Python, R, Julia. We could also set up, now there is a Stata, let's say, kernel for programming in Status. And here on your right, you see one example of notebooks where you can see there are part with the documentation and the part that actually you can actually let's say execute on the infrastructure, right? So this is one part, but we're going to see this in the demo as well. For those that are keen with R, maybe are more accustomed with RStudio, the VLab and the FOSSR-VRE through its VLab offers an integrated development environment for R. Even in this case, you can choose the server features in terms of number of CPU cores and memory that you need for doing your research. And then you click on RStudio, and then you will be presented with an RStudio environment that you can use to perform your research. Even in this case, for those that are keen with R, this is an excellent tool for doing research. And then we go to the one service that is, let's say, being developed, and this was developed in the FOSSR, and we make it available in the FOSS-VRE. Is called CCP, or Cloud Computing Platform. This is its interface. This is the actual one of the service that we are going to demo in a few minutes. And its main features are the following. So the CCP, the Cloud Computing Platform, offers a per method web user interface and REST API access via standard. You can import your algorithm, your method, with a dedicated tool which supports any programming language. It offers a number of algorithms, a number of methods as a service that you can execute already in infrastructures, but also automatic code generation for Python, R, Julia, and IPy notebooks. And it automatically does provenance management for you. So whenever you execute a process, the provenance is, let's say, managed internally. How does it work? Very briefly. So you arrive with your method, your script, your algorithm, your software. You can import it in the Cloud Computing Platform by specifying, say, the Docker image, where to start from, and the input parameters it needs. And then you have a resulting web user interface and web APIs that any member in the VRE can use to execute the process. Now, every execution that you do with this tool is automatically stored in the cloud storage solution that we offers. It's called Workspace. So you can see here a screenshot. So whenever you execute something, let's say the result of the computation along with your input method and the method descriptor is stored in the cloud storage solution in a dedicated folder in the cloud storage solution. But also you can launch the methods, the algorithms from within Jupyter. So suppose that you have an algorithm that takes some requires a lot of computational power and cannot be executed inside a notebook per se, then you can import your method, your algorithm in the cloud computing platform and execute it from Jupyter Hub. We will also showcase this feature. Now, before going to the demo, let me talk about the provenance, because provenance plays an important role in data science, we all know, because experiments are often developed iteratively and they involve multiple execution with different versions of data sources, accessing multiple application infrastructure service. So the CCP, the cloud computing platform within this, the FOSSR-VRE, adopts this ontology. It's called the Provo ontologies, which expresses the proof data model using the OUT2 language. Here in this slide, you can see one example of one execution that was ran in the cloud computing platform. So each execution generates a proof document where you can see, for instance, the start time of the execution, the end time, the person who executed the computation, the name of the algorithms, the name of the method, and the version, the description, and another information about this. So now I hope I have stimulated your curiosity. So we have this live demo time, and I will give the floor to Alfredo for doing so.
Hi all, I'm Alfredo from East CNR, and let's share my screen to start the demo. Okay, can you see my screen?
Yes.
Okay, so starting from the FOSS gateway, signing in, we have access to the data, as Massimiliano introduced it, we have access to the dashboard, the gateway dashboard. We can see on the left my workspace files and the list of virtual labs. In this case, we have only one virtual lab, the FOSS Virtual Lab. Entering the virtual lab, we can see all the tools that Massimiliano shown, like the Jupyter Lab, the RStudio. On the right, we have the shared documents. And in the specific of the CCP, we can access the CCP entering the analytic engine. The analytic engine is composed by two different pages. The first one, the CCP platform, is the page that we use to navigate the catalog, to execute the methods, and to monitor the execution. We have a different page that we will just introduce, but we will not see during this presentation, that is used to define a new method, to manage the existing one, to edit or to modify them. So returning to our catalog, we can see on the left the list of already defined catalog for this in this platform, in this virtual lab. Excuse me. As we can see, the catalogs are organized by categories, and we can see a list of catalog of methods that I prepared for this presentation. For each catalog, we have a name, a version, an author, a small description, some tags that allows us to catalog and to search them, and a list of buttons to interact with them. Like we have a button to play, to start the execution of the method, a button to download its definition. It's a JSON schema that defines all the methods, parameters, architecture, and stuff like that. A similar button, but that do the same, but archives the JSON in our workspace, just to archive them, and stuff like that. And a button to share the method. Actually, these methods are private for me. I'm working on them. When I'm ready, I can share them with the community, and they became available for everyone. Like, for example, this one has already been shared, and everyone in the community can see and use that. So how to execute a method? We can drag the method in the form, or maybe some browser has some issue. Just use the play button on one method, and the method is loaded in the execution form. As we can see, the execution form has a small description, but as also we can see the runtime, so that it's the Docker image used to execute the method. It can be a generic Docker image like that one, that is just a Docker configured for Python, or it can be a specific Docker image. We can prepare a Docker image with all dependencies, code, and all the stuff that we can need for the execution. So we have a specific image prepared for one method or a series of methods, or shared between a series of methods. And so we just need to instantiate this instance and run the algorithm that we implemented. We have also some parameter for the execution of the method. In this case, we have only it asks only to upload the file that will be processed. It's in this case, it's required a text file. Our algorithm will process this file and generate a word cloud. I was choosing for something a little bit interesting to show. So this algorithm will process the text file, make some statistics on the word, extract the more used word in the file, and draw a word cloud that represents the more important, the more used word in the text, and draw that in a artistic way, we can say that. Another very important field is the annotation for execution field. We can annotate the execution, so maybe webinar presentation, and we will annotate this execution and the results with these labels, so we can immediately find in our execution monitor list the result of or the instance of one execution. We have some marginal options that decide how the output will be archived. Maybe usually you can archive the full execution, we archive only the outputs of or do not archive anything in our workspace and just let process and show a download link for the execution. Let's start our execution. We have compiled all the fields that we need, in this case, only these two fields. So we can start the execution. It's important to evidence that it's an asynchronous execution. We ask the infrastructure to schedule for us an execution of the algorithm with the given parameters. We can monitor its execution, but we can close the windows. We can access this execution by other instances because it's scheduled. The system will run for us this execution and will we will be notified when the execution is finished. I'm polling now manually. This window periodically updates. We can see we have now a new execution that is scheduled for the word cloud. We can expand this. We see it has been accepted by the engine. We can see the logs of the execution. It's not still started, so it's still empty. And we will see there during the execution all the logs of the system, of the algorithms, and stuff like that. I will now, waiting that it starts, see how we will found an execution. As you can see, it's I tested before the presentation. This execution is an execution of the same method with a different tag. We can see the time of accepting, the timestamp of that the execution has been accepted. We will find here the timestamp for every operation, for the last operation. We have an output that has been generated. We had the same input, so the output will be the same, waiting that it's processed and executed. So by pressing the output link, we download a zip file that contains the input that we submitted. In this case, was I searched for big texts to use as an example. That way, now it's the American Constitution. I found that quite useful. And the output is for us word cloud, an image that takes the 200, in this case, more used word, size them in a size that is proportional to how many times they has been found, and stuff like that. As we can see, the execution of our method is started. We can see the logs of now is the logs of the deployment. Then we will have the logs of the execution. Here in the execution monitor, we can see some buttons to interact with the execution. They are quite important because it's what Massimiliano introduced for the provenance to monitor the provenance of data. We have links for open an instance of the execution of the CCP configured with the same parameters that has been inserted. We have we can generate code to execute programmatically the same instance. We can archive the results in our workspace, or we can resubmit the same instance in the CCP executor to re-execute with same data, prove that data were provided correctly. Okay. At the same way, we have here under the definition of the method a direct link that we can put in our catalog or share with colleagues or put in our research, just to link the instance of the catalog that can be executed, so we can document our methods. Let me see how it's going our presentation. Still waiting in a second. Okay. We saw now a very small, very simple method that just asks for us of a file, but we can obviously have more complex algorithms. Like, for example, I prepared this one that use the same libraries but expose more parameters that it can offset. Like we can change the size of the output. In this case, we can obtain our files not by our computer, but in a more shareable way from the workspace, the shared workspace. So we can prepare data for the community and use them inside our algorithms. I prepared, for example, now we are, for example, going to upload the Alice in Wonderland full book to be processed. So we open that directly from my workspace. We get the link to my workspace. We can, for example, in this case, provide a file with blacklist word that we don't want to appear in the results. That's an optional field because it has the star. So we can skip that or provide that. We can provide a different file, an image file that will be used as mask. I like this example. It's going to be quite nice for me. For example, we're going to take a parrot image and dispose the words in this way. And stuff like that. So we have a lot of other optional fields that we can fill or not, different kinds of parameters accepted by the method prepared. We will see maybe if we have time how to prepare a method, define these parameters. Then we have our annotation for the execution. Okay. So our old presentation is running. It's already finished. It's just undeploying the instance. We can already see the result of the webinar presentation instance. As you can see, we have the same input that I proposed before. So the output will be similar, different disposition because it's random, but we have a new instance. We can, as we see, the new instance of the parrot is started. We're waiting for the execution. As Massimiliano introduced, we can instance the method and run it directly, for example, programmatically. We will try now to do that from Jupyter Notebook. We just select for Jupyter Notebook. We ask to download this notebook. So we downloaded a new file, a new notebook that is configured to execute this method with these parameters that are not this one, but that is from the first one. So opening the Jupyter Lab, as Massimiliano showed, we are asked to decide which the specification of our virtual machine. We can go for a small one because it's not going to do anything except ask for an external computation. We instantiate our virtual machine. Okay, as you can see, I have already a notebook inside because notebooks are not persistent in the virtual machine, but are persistent in my workspace. So they are persistent between sessions. I can find the old result, the old notebook in my space. I'm going now to take the downloaded notebook, add that to this instance, just dragging it. Now it's going to be uploaded, deployed, and we will appear in a few seconds. Here we are. So we have our notebook. Okay, so the system generated for us a notebook that authenticated us. It will ask us to give him our password to access the system because it needs to authenticate it as with our user. We'll obtain the token to interact with the system. We'll start the execution of the method in the CCP platform. Then we'll poll for the status. We'll continuously ask information about the status of execution. Will update us about this status, and will provide us the output as a zip file that will be saved in our workspace. Let's try. As you see, I have to put my password. Right. Let's retry. Okay. We can then obtain our token. Okay. Start the execution. Okay. And then start the polling of the status. As you see, we can see that the execution has been accepted. And periodically, our algorithm, every 2 seconds, every 5 seconds, will ask for an update. As I told you, we can, that's an asynchronous external execution. We can monitor that. Let's return to our Cloud CCP page. Our monitor will have track of also this instance. As you see, we just started this instance, and we started that from the Jupyter notebook. But we can see found that in our monitor, and we will follow it both from both the execution monitor or the Jupyter lab. Okay. Let's see now if the Parrot instance has finished. To close that, open the advanced. Okay, my webinar Parrot has finished its processing. We've provided different data with different parameters, and now let's see, something is wrong. Okay, we've lost something. Let's see, I don't know, maybe some wrong parameter. Let's open the old instance. It was supposed to be something like that. No. Okay, let's see. We generated an image like that. I really like that. Providing as input, we saw the Alice Adventures in Wonderland book, and using as mask this image. We can see that it's related. Okay. Let's see a little bit of how a method is implemented. In the method algorithm importer, we can see the same method list that allows us to manage the existing methods. Or when we open it, we have an empty interface of the editor where we can define a new method. I think we will start with an existing method just to see how it's made, instead of to define everything. So as we can see, we have a title, a version, a small description, the keywords that we find there, the categories that will finish. We'll organize our method in the catalog. The infrastructures where we can run it. Now we have available for this VLab only one infrastructure. We could have more than one, so we can decide that one algorithm is target to an infrastructure or to another one. Then we have the parameters that we were supposed to populate before the execution. As you can see, we have a list of parameters. We can add that from this interface. The parameters are typed. We can decide the type of the parameter. We have, for example, in this case, it was a file. We expected a file from the workspace, and then interface will provide us a widget to select it. We have numeric parameters. We have, I don't know, in this case, the CCP node that was for the execution, that it's a specific type, and stuff like that. We have then, we can decide if or not make a standard output and error available. And we have the deploying scripts that instantiate that configure the environment for execution and that execute it. So I don't think that you're supposed to write your own method. You will be more user than the developer of these methods, but just to know how a method is defined. I don't know. Let's see if our execution is finished. Okay, I touched the code and it's telling me this. Still waiting for the execution. Okay. To finish, we can. I would like to provide you the link for the documentation of the CCP in general for our platforms. You can find all the documentation inside the how-to, or you can find that also. Wait for me for that. Here in the Learn More section, it opens the same documentation where you have a small introduction, a quick start that drives you in the interface details, and then the execution and monitor widgets. And we have also an implementation reference that explains how to implement your own algorithms. The basic, at least the basic, the main aspects. I think that's all waiting for this execution. Still waiting to start. Thanks.
Okay. Thank you, Alfredo. Thank you for the demo. So we can, if the audience have any question, we could take some questions now before they wrap up. Don't be shy. Yeah. There is one question. Lorenzo. You can unmute.
Yes, can
Hi.
you hear me?
Yeah.
Hi, I'm Lorenzo, the CEO from Lewis University, and I work on electoral studies. I think I would like to thank you for the presentation. I mean, these developments, I found them quite exciting. And I have very specific question. Now, the first question is about the workspace feature, because I have seen that all applications. I have also tried to play it a little bit with my, I logged in into the platform, and very nicely, everything is able to pick up files from the workspace. Now, will there be the possibility of having the workspace synchronized externally, say, for example, with a GitHub account or with some external client that synchronizes files on the desktop, which means that it might be easier rather than uploading files through the web interface? That's the first question. And the second question, I think it's quite obvious questions that gives more value to your presentations. That is to say, this is the FOSSR demo lab, and I see an option for adding, requesting their own labs. And I would like to know whether this is a feature that's already available or when it will be available in the future to start working with our research group.
Thank you. Thank you, Lorenzo. So about the synchronization between a desktop or a GitHub part with the workspace, we do not offer this say feature out of the box, but every service is that you can interact with as web APIs, as REST APIs, sorry. So it shouldn't be an issue, let's say, to write a very small, let's say, script that reads the content from a folder and uploads it in another specified folder on the cloud storage. I hope this answers the first question. Now, about the second question, that is a very good spot. We didn't show that. Let me share the screen so we can I can try to explain a little bit. I guess you were referring to, just give me a second to find my browser in the sharing window. Where is it? There you go. So you, if I understand well, you were referring to this part here, request a new virtual lab, right? Exactly. Okay. Yes. So we do encourage you to ask for your virtual laboratory, and that is why we have placed that button there. So by clicking here, you can specify a name, an abstract, and upload additional materials. We will receive that. We will contact you, and we will start the process to define your own virtual lab. What we have put here is just, let's say, a virtual lab for us that would, somehow show most but not every features and every service that we can add. It is also possible, for instance, when defining a new virtual lab, to import a custom application that you use for your research by means of containerization. So yeah, so yes, please do. Do we have another question from Giuseppe? Giuseppe Sindoni?
Hello. Yes. Let me just. Yeah, I have to look to the other screen to see that I'm looking at you and not as well. Yeah, my question is about if the platform manages also personal data, because in the demo that we have seen today, we saw textual data not containing any personal data. So does the platform assume that the data are in any case already anonymous, or does it cater for personal and identifiable data and then gives the option of de-identify the data?
Okay, let's start from, that is a very interesting question. Thank you, Giuseppe. Okay, let me start by also adding to reply to this question that, so we can attach, let's say, to each virtual lab a terms of use that the user who enters the virtual lab has to accept. And in this way, if the user, we make the user responsible for the data he or she uploads. We do not offer, let's say, a anonymization or de-anonymization tool per se, but the way we approach this is by attaching a terms of use to accept when entering a virtual lab. That you can also collaborate a lot with writing the terms of use needed for using the facilities in the virtual lab. Hope this answers the question.
And of course, I mean, I forgot to thank you for the very, very interesting demo and the platform is very impressive.
Thank you, Giuseppe. Is there any other question from the audience? You can also write in the chat if you cannot use the Microsoft. Okay, it seems there are no other questions, so I have just few slides for the wrap up, which go and touch very slightly the services, the tools of the virtual lab that we haven't showcased in this demo. So let me restart, try to share the presentation once again. Okay, so one part that was missing in this demo and this presentation, and we did not touch it because it would have required a lot of time, is the publishing part. So how, once I have obtained some results based on the computation, how can I share my data sets and the methods with the others? And the FOSSR-VRE promotes this, of course, as open science tool, this kind of, let's say, practices. So the VRE, so as a tool for, let's say, sharing of the data set with the others, it is possible to, let's say, make available in the virtual lab what we call a community tailored catalog. And what do I mean by that? It means this is basically a metadata catalog, data catalog that is capable of, let's say, the user could publish any research product, and the community using the virtual laboratory can define the type-specific metadata that are useful for that kind of research that the community is accustomed to do it. So in this example here, you see not the FOSS catalog, but one other instance of the catalog that I'm just using as an example. This was the catalog that we have developed in the context of RESIS2, a European project. It was called Open Data VRE Catalog. Here you can see that the products can be browsed by a number of dimensions, and it is you see here in below, each research product can be associated with a type. So in this specific case, you can browse by types, and you can see dataset, publication, other software, and the community can decide which metadata profile to attach for the definition of the product. What we also have in place is that this kind of catalog, for instance, if you publish a notebook, it could also have a link that a user can directly use to open the notebook directly in the virtual lab. Or if you publish a method of the CCP, you can have an actionable link that takes you to the direct execution of the method in the VRE. Finally, each virtual lab has a number of members. We did not touch that, but in the FOSSR lab, this is the list of the members so far. Now we also have our colleagues that have been registering while we were doing the presentation. And each member of the virtual lab can also specify his let's say profile, his background, and the platform allows the members to interact with each other by means also of a private messaging tools. And yeah, the memorization, and I think I'm done for the presentation, and I thank you for attending this event. I encourage you to go to foss.d4science.org and try yourself. And we are, of course, available to any request of new virtual lab, as was Lorenzo was subject of Lorenzo, but also to any, let's say, request offline of other, say, other kind of requests.
Yes, I'm going to share today the methods so you can use them as example just to play with the platform. And I will put the data that I used in the shared library, in the shared folder.
Okay. Is there any other curiosity or question from the audience before we close? Okay. In this case, I guess, Alessandra, we can close.
Yes.
Yes.
Yes. We thank you for the presentation, of course. It was very, very interesting and very useful. And yes, thanks to all the attendants. And yes, we will wait you for our next steps, seminars, workshop, and so on. So please check our website for any information. Thank you again to Massimiliano and Alfredo.
Thank you. Bye-bye.
Thank you very much.
Bye.
Bye. Thank you.